Thanks for the introduction. Yeah, good afternoon, everyone, also from my side. I'm sure I'm sure most of you followed one of the previous talks from Robert Zukob regarding the DT project Access 4.0. I'm part of the engineering department in that project, and my role, of course, together with a few colleagues, is to take care about all the access node related aspects. So that includes the physical component as well as the virtual component like the VOLTHA, what I would like to talk in one part of my presentation today. Yeah, out of that role, I would like to give you a little bit of more detailed insight into what is happening in the Access 4.0 project regarding the access node, regarding the hardware abstraction of the access node. For that reason, I structured the presentation in three major parts. The first one, I would like to talk a little bit about the VOLTHA things, what happened in the past, what we will do in the future. The second part is related to some aspects of the DT data plane related workflow, and the third part is related to the DT activities regarding open access hardware components. So let's start with VOLTHA. So maybe first of all I should mention that that most of our contributions are related to our partnership or cooperation with the Redis guys, and therefore some of that what you will see right now you might have already heard under the flag of Redis. So on the left hand side you can see what we brought in as changes or improvements or additional features in the past to the VOLTHA project. Of course, that's mainly related to the core versions 1. something and to the older adapter versions like the ASF Volt 16 adapter for the OLT and of course the Broadcom ONU adapter. So, but all of these features are 100% motivated by the Access 4.0 requirements. So that's that you can see on the left-hand side. That's the registration ID for the ONU activation and authentication. That is the use of multiple PON ports per OLT. That's also the using of traffic shaping functionalities, like it comes from the PON protocol itself, so like the dynamic bandwidth allocation and so on. Of course, an important aspect for us is transparent flow handling for the FTTB use case. That's pretty much important for us and maybe not of a big interest of other operators. Therefore, we took this opportunity here to be engaged on that. Yeah, also the flexible usage of one of the 4 NNI ports is one aspect. The OLT and ONU reboots is another one. And that's also pretty a little bit special for DT, the handling of the LLDP. That's what we use for our workflow in DT. So that's what we did in the last 1 or 1.5 years together with the Redis guys. And yeah, on the right-hand side, I have highlighted a little bit what's going on right now, what's the actual activities, and that's the main aspects in the current time frame is of course the adapter the core changing is a major aspect, but from our perspective, the adapter changings from the ASF Volt 16 towards the OpenOLT. And from the Broadcom ONU to the OpenOMCI ONU adapter, that's pretty much important these days. And in that particular area, of course, the support of the design and implementation work of the resource manager and the tag profiles. That's a very important aspect from our perspective. And of course, that's self-evident, the adaptation of the Access 4.0 motivated requirements which were developed in the past for the old generations of the adapter to move or transition or towards the transition to the new adapters. That's of course another one. In the DT project, we have established a kind of a field trial which has some other relations to the management layer, and that is because we have a little bit different in that, and therefore that prevents us for the moment to go or to move from the old versions of the adapter to the new ones, but we are pretty close to that, and we will do that transition in our field trial starting of next year. So let's go to the next slide. On that one, I have listed what we have in mind for the near or midterm future. In terms of VOLTA, of course. So of course, there is the self-evident things like full support of the DT use cases, and as Robert mentioned in his talk, that is FTTB and FTTH, the development or the delivering of internet access for FTTB and FTTH. That's our main focus, and we have to see the full support of these use cases with the Open OLT adapter, and of course, not mentioned here, but of course with the Open OMCI ONU adapter as well. So the containerization of these adapters is an important aspect that it's already addressed, and the work is already in progress on that. It's scheduled for the VOLTA 2.1 release. That's also an important aspect. All this including the transparent data flow handling as we need for our use cases. That of course we should go from or we should move from the feature to use any of the NNI ports to use multiple of the NNI ports. Also, that might become of a special interest in the near future. And of course, for the FTTB use case, we need the DPU support in the VOLTA framework. Whatever that means, so there are different ways to do it or different level of reaching that goal, but yeah, at least the most simple one we have to address pretty soon. All these are feature-related things. That's for sure, we have to address it. We have to enlarge the feature set of the adapter and of the core of the VOLTA framework itself. But nevertheless, there are more aspects than only the features. And that's what we have addressed in the lower bullet points. That's, of course, the scalability, ability, and performance. And that means not the scalability and performance of a single component of the VOLTA framework, for instance, of the core or something like that. We need all these for the entire end-to-end solution. So that includes the core, that includes all the adapters, that includes some other components which are not developed in the VOLTA framework, in the VOLTA project itself, which comes from other projects. But all these together has to satisfy operator needs in terms of scalability and performance. And for that, we have to address several things. From our perspective, first of all, we have to agree on dedicated numbers, some kind of KPIs. What level of performance we absolutely need for an operator deployment. Maybe these numbers differentiate a little bit from an operator to another one, but we have to talk about that and define a common baseline on that. Then, of course, we have to do some testing or analysis, maybe with a BBSIM or with an improved version of BBSIM. We heard about that in the talk of Saurav. That could help us to investigate, to analyze the performance capabilities of the current version. And if there are, or if the result shows some weakness in that, we should decide to do a similar step as we did for the core, to move the coding language from Python to Golang or something else, whatever will help us. We should make such kind of decision as soon as possible to avoid a lot of development on an old approach, and then we come to the same situation that we have to move already developed features or things from one basement to the other one. So that we should avoid, and therefore we should address especially that thing or that part as soon as possible. And of course, on the last two bullet points, I have mentioned two other aspects which are of our particular interest, but I strongly believe it's also of a particular interest of other operators, probably of all operators. So that's one thing is the device management, and the other one is the reporting and retrieving of KPIs, of alarms, of counter values, and things like that. That's, these two items are very critical for a real deployment of such kind of a solution. So maybe it's not that critical for a field trial, for a lab trial or something like that, but for a real deployment it is essentially. And therefore also these two items has to be addressed pretty soon. And yeah, nevertheless, at the end, we would like to motivate the entire community. That includes the ONF, that includes the operators, and of course the hardware manufacturers and chipset manufacturers to do or to incorporate more than only the features which are very recently needed by some field trials or some lab trials. So it is more important to incorporate a kind of flexibility in all these layers of abstraction. So that includes the Volta, but also some other layers, also in the ONF or whatever. We need some more flexibility to address different needs from different operators, and also to avoid a kind of nasty situations in architecture discussions inside the operators. So there we need such kind of flexibility. Of course, that needs that needs some more resources, and we are aware of that, and we are willing to support and probably also to lead some kind of these activities in the near-term future. So as Robert told, it's very recently we have contracted an integrator, and out of this situation we will probably be able to spend much more resources than in the past. Okay, so now I would like to come to the second part of the presentation. That's regarding the workflow, the data plane related workflow for the DT use case of FTTH. I have structured it in two aspects. One is related to the PON layer things. The second one is related to the data link layer things. So on the picture you can see roughly how we structure the PON architecture today. In our FTTH use case, we are using a simple bridged ONT with a single Ethernet interface towards the customer. So on the drawing, it is depicted with the managed entity of the PPTP, of the physical path termination point. Of course, if you go from that single OMCI managed entity towards a dual managed entity, like an integrated home gateway with a ONT part, then these kind of interface will change from a physical one to a virtual one. Then you have there a virtual Ethernet interface point, but the PON architecture itself will remain. So in that we are using 8 queues related or combined with 8 gem ports, where we map into based on the p-bit value, and then we use a single T-con towards the OLT. That's no fancy things, that's pretty easy. And the OMCI, so the management path of the entity, is a separate one, which is not depicted here in the drawing, where we use a second T-con with a second gem port. So what happened now? If a new ONT is connected to the PON tree, the regular and well-defined in ITU-T processes starts running, and the ONT will be recognized by the OLT, and then a kind of a port up message should be generated inside the PUD to the PUD management layer, which contains at least the serial number of the ONT, hopefully or probably also the registration ID, as we use in our legacy use case. And these kind of IDs will be forwarded upstream to an outside of the pod, to a management layer outside of the POD, which contains these information, which correlates these information, and federated with other information from other support systems. And then at the end, it will be recognized as a valid one, and the user subscription is recognized. And then downstream, all the necessary information will send to provide or provision the data path on the OLT. So yeah, that includes the assign of an ONO ID, that includes the assigning of a line profile of gem ports and TCONs on the PON layer, and of course it includes the assignment of the S tag of the outer VLAN tag or whatever it is on the OLT, which is corresponding to the ONO ID or to the customer. So that means in our architecture we are using a kind of a VLAN cross-connect model where we identify a customer with a dedicated S tag. And if everything's set it up, so the data path is finally established, then the PPPoE process starts running. And for that, the customer authentication will be done on the PPPoE termination, which in our scenario will run on the leaf switch. And then finally, we will address a public IP address to the home gateway. After that PPPoE session is established between the home gateway and the SE, then all the services are running as a unicast service inside that PPPoE session. Also the TV services, the video services. So we have no multicast between these 2 points. And the differentiation of the services is being done based on the pbit values in the outside VLAN tag. Especially for that, we need, that's mentioned in the frame on the left-hand side, especially for that pbit assignment, we need such kind of flexibility, as I mentioned before, because we have not a basic copy for that or something like that. So there are some kind of special rules are needed to fulfill our deployment model, and therefore we need this flexibility there. All the other things I already mentioned. For the C-tag values, that means for the tag values coming from the customer or belonging to the customer, the entire range must be addressable, because we need a fully transparency at that point of view. And also the ONT in our scenario is fully transparent regarding layer 2 information. So yeah, that's more or less all we have, or all I have for the FTTH use case. The FTTB one is a little bit different. We have some other handling on the layer 2 level, moved from the OLT to the DPU. But yeah, it's a little bit. It's not changing the process completely, but it has some different aspects and some additional aspects. Of course, you have another element in. So the last of the 3 parts is related to the open hardware. That was also mentioned in the talk of Robert already, that we decided to to publish our own OCP specification regarding a GPON-based OLT. Yeah, what was the motivation to do that? That's depicted on the left-hand side. So what we see today in these VOLTHA and SDN-based access project is that also there the ecosystem of the white box OLTs or access nodes is not that big. So in our legacy systems, we complain a little bit that the ecosystem of potential vendors, hardware vendors or hardware manufacturers is not big enough for reasonable competition. But for the moment, we see more or less the same situation here. And that's not what we as an operator wants to see. So therefore, the idea is to motivate more white box manufacturers or also gray box manufacturers to step in to provide hardware. What we have seen, at least during the BBWF on the ONF booth, that there are more than only the edge core box today. So the ecosystem develops more and more, but to be honest, we would like to see a little bit more and also more flexibility in terms of the technology. So what we have seen is that there's a big focus on XGS-PON, but from DT perspective, the GPON, at least for the next couple of years, plays a significant role as well. So at least for what we would like to address, we would like to address mass market internet service or data service. So therefore, the GPON is sufficient for the next couple of years, and from our perspective, much more reasonable from the pricing perspective. Yeah, all that thing brought us to the decision to contribute our own specification and brought it in and publish it on the OCP. And then we had to talk about what would we like to do? Would we like to reinvent the wheel, or would we like to create something that not only DT needs, that all others needs as well, or most of the operators could need as well, and we need it in a reasonable time frame. So therefore, we came to the decision to reuse existing things from the AT&T-based XGS-PON specification. That from our intention on that point was that we can reuse some of the open source software components. We can reuse the same hardware abstraction with VOLTHA, and that brings us a solution much quicker than a completely new one. Of course, the other things are self-evident: to use merchant silicon components as we have it available today, and also comply to relevant standards, at least on the physical layer, but also on layer 2 and 3. Yeah, and also the cost aspects are relevant, of course. So all these guidelines brought us to that kind of OCP spec, as you can find it public available on the OCP server today. Here I just briefly mentioned some major aspects from my point of view inside this specification. So it's based on the same chipset, on the same chipset combination as we have it for the XGS-PON version already. So that comes from the idea to have or to use a lot of commonalities to be quicker, of course. Then we have created two different versions. We have created, not really created, but described a 32-port version and a 64-port version. The 32-port is a 1 rack unit high. The other one is a 2 rack unit high version. And from our perspective, that fits perfect to chip granularity, to uplink capacity, and to central office sizes and things like that. Of course, redundant power supply is in, hot swappable fans are in, all these regular things. One aspect I would like to mention here is that we created a kind of flexibility in terms of the uplink. So we had the 100G uplink option for the use of these box inside the POD, very close to the fabric. You can use the duct cabling there. But we have, beside that, we have another option with the 10 gig or 25 gig interfaces if you have to transmit several kilometers between your fabric and your OLT, if you use it in remote site locations. Another aspect is that we are not anymore in the data center. We are in a telco environment. Therefore, also the lifetime might be a little bit different. So we are not planning to throw everything away after a couple of years. So we think at least 10 years of usage should be sufficient. That's a little bit from the background, from the telco background. That's also one aspect with a 2-rack unit high. You can use bigger fans, slower fans. Also, that has a better lifetime than the tiny ones. The control software interface there, we are not very precise in that specification because from our perspective or from our standpoint, there's a lot of movement already that's not really finally discussed in the community, and there we will see a few changes in the near-term future on that. So that's just briefly a picture of what we probably can touch beginning of next year. So yeah, that's more or less everything. So here on that last slide, I have summarized a little bit what we have in mind to do in the very, very near term. So that's, of course, we will provide. AT&T has already, Turk Telecom has already, but we don't have, but we are still working on that very hard. And hopefully we can pretty soon provide a detailed DT workflow, not only for the data plane, also for other aspects, to bring it into the SEBA project. Then we will intensify our contributions to VOLTHA to establish the full support of our use cases, of course, that's the main interest, but also to incorporate the DPU for the FTTB use case and to address end-to-end performance and scalability questions. One of the other aspects is that we would like to establish a community-based VOLTHA/SEBA lab setup in Berlin. We used that facility already during the BBWF staging. And we would like to use that further with a kind of a lab setup with a strong focus on the access nodes. That's what I'm responsible for. So therefore, that's my focus. But of course, we will create, not finally decided how, but we will create an environment where that can live and which reflect also the DT specifics from the Access 4.0 project. And of course, the open hardware story is not finalized with the publishing of these OCP specification. We also will further work on that, maybe with the usage of different chipsets inside such kind of boxes, or with additional options for using in remote sites. Yeah, that's the list for at least the next 6 to 12 months. And yeah, that's it from my side. Thank you for your attention. And I think there are a few minutes for some questions. That's a good question, and honestly speaking, it's not finally decided. Also, luck is absolutely an option, especially as I saw, or as I mentioned, that we have these remote site location. We will use some kind of WDM system in between. We are in favor for a passive WDM system in between that has limitations in terms of capabilities, and maybe to using two 10G options in a kind of a link aggregation mode would be helpful for that. But it is an architecture discussion which is not finalized in DT, but at least to have the option is important for us. And also, on the other hand, a kind of resilience to establish links to two higher order nodes is also an option, which we have in the architecture discussions. And for both, we need the support of multiple NNI ports. Of course, that's maybe not the aspect we have really on top of our list of requirements. So maybe it's more reasonable to finalize the discussion inside our architecture team and then come with a concrete requirement that might make more sense. But on the other hand, it also gives us more flexibility if we have the support of that. So as I mentioned already in our talk, we will provide a list with requirements, probably a long one, but we will structure it with some prioritizations, and maybe that one is not the top of the list.
Can I ask another question? So
of course.
On the lab you're going to have in Berlin, is that something you're going to provide your part or the setup in the end-to-end Deutsche Telekom's flow scenario, or is something it's a service provider independent? So the community, if they want to access that part, they can just remote access that part, or what is the purpose of the lab you're thinking about to be turned up in Berlin?
Actually, the current discussion we have focus more the second one, because we have several setups in the other location in Darmstadt, in our main engineering location. We have several setups of PODs with a full DT solution there. So maybe it's not needed to replicate that another time, just in another location. The idea is more to have a more community-related version there. And then we will see how to link these things together. Of course, at the end of the day, we have to link it a little bit to our project. That might necessary to get the approval for that. But the main focus is to have it more on a community basis.
When you say community-based, means you are planning to give access to other people?
Yeah. In general, yes. But how in detail? That's not finally decided. So that's still in progress.
I think as a community, we definitely appreciate that kind of setup. I think I actually think about AT&T would also provide something like that. I think that's the idea we had last year. I think a lot of software developers, they don't have the hardware in their environment. Okay, but they do want to be able to implement their code and test it. Thank you.
We move to the next session. It's the last session, so we don't have time to proceed. If you have any offline questions,
Yeah, I'm around here for the next 2 days, so feel free to ask me.